My name is Loic Barbou. I'm the FIMS Technical Board Chair, and today I'm going to talk about the FIMS Repository Interface version 2.0. So before we start with the 2.0 versions, let's go back to what exists today as part of the version 1.0. The repository version 1 was completed in 2004 as part of the release FIMS 1.1. The version 1 really implemented the capabilities of exposing a physical repository interface to abstract a system like MAM, regular storage, and post-production system. Within the scope of 1.1, we provided the capabilities of managing essences, to manage object metadata, as well as the ability to query those asset metadata. For the version 1.2, we're adding some new capabilities to the interface. We're starting by adding the object relationship support. So that's really providing the feature sets that enable linkage of assets together. And I'm going to go into those details. We're also adding new features that is to manage external essences to the repository. And the last one is virtual asset. That's a brand new concept that allows assets that do not already exist to be managed within the repository itself. Those access are basically pointers to other assets. So at the end of the day, those three new technical requirements that we're adding, what are going to bring to the repository itself in terms of features? Well, the first one is to fill a gap that exists today within the repository interface to implement all of the operations of the MAM product. The second one is the implementation of what we call the logical and federated repositories, where you have a repository that has the ability of keeping track of content that exists somewhere else. And the third one is to also implement construct like IMF and IMF payload within the repository interface. So before we get into some of the details, I just want to go back and describe how do we represent a FIMS asset. Well, the FIMS asset is divided into three different logical layers. The first one is the BM content type, and that's actually the name of the object within the FIMS schema. Within that layer, you have the ability to describe an asset by its identifiers. The second one is a descriptive metadata that is built on top of EBU core. Well, an asset itself represented by the BM content type can have many format representations, and that's represented by the relationship here. So each format, following the same principle, can also have many essence locator, meaning the physical files that may be located on different storages. So that's basically how an asset looks in FIMS. So using that same asset now, I'm going to describe some of the new features that we're adding to the repository. Okay. So the first one is object relationship, and what we call the strongly typed. Okay. So it's what is a strongly typed relationship? Well, it's a relationship that you define that exists between two different assets. Well, that asset, as an example, that relationship represents a linkage between two assets. In this scenario, it's an is-parent relationship. So it means that the asset that is here is actually a parent on that one. As you can see, the linkage is done at the BM content type level. And you can actually create a relationship that exists at a different level of the FIMS object as well. It means a different thing, but we provide those capabilities. Okay. As an example, you can say that the essence of that same asset is derived from a different asset. Yeah. Okay. You can also define custom relationship. Okay. There's a list of predefined relationships that are the basic one, like as I said, the parent or even is derived from. But you may have within your media ecosystem relationship that exists for the type of a business that you're in. In this scenario, is master, if you're producing master, is something that you can create. The repository allows you to create and define strongly typed relationship that you can reuse, and that's part of the repository capability. They stored in the repository capability registry. Okay. When you define a relationship, you also have the ability to specify the inverted relationship, and that inverted relationship can be created automatically depending on the capability of the repository that you have. So in the scenario of an is-parent relationship, if object A is a parent of object B, it means that object B is a child of object A. So that's an example of an inverted relationship. Okay. As part of expanding the schema, we also added new operations to the repository interface to manage the relationship themselves. So with those operations, you can create, update, manage those relationships, and you can also query them. Very important in order to properly browse and find the content within your repository. Strongly typed group now. So that's a different type of relationship. So within the context of FIMS, of a media workflow, you may have the need of grouping assets together. So that's a construct that existed in the foundation of the schema, but that was never really managed by itself. With the update that we're making to it, you will have the ability to now create a grouping of assets. In this scenario, I'm defining work order, and as part of that work order, I need to do some work on those 3 different assets. So it can actually be built with this. As a second scenario here, I may have 2 assets that I want to distribute at the same time, and that's part of creating a package. Why is that important? Well, through my media workflow, it gives me the ability to now address those collections, those grouping of assets as a whole, in terms of transcoding, in terms of transfer, in terms of QA as well. Okay. And part of creating the group, not only the definition of the group, but we're also adding the operation to manage the group themselves. Dynamic linking. So that's something that I'm sure everyone is familiar with, because it's not a new concept. It's something that we've all used in the system that we have built. So it's really using the metadata or the properties of a given object and grouping those objects based on the value of that metadata. In order to simplify the implementations of that concept within FIMS, we created a new property that is available at the different layers of the FIMS objects, at the BM content type, the format type, and the essence locator type, that is tags. So what is a tag? A tag is a value that you create, and you assign that property bag of values to that specific properties there. It allows you to drive operations in terms of querying or finding the content based on the value of those tags. Okay. So as an example, okay, if I have, let's say, 3 assets here, for the simplification of the slide, I've I compacted the representation of the FIMS object here, but each of those collection of the tags has one of the value of a president. It means that if I want to create a logical group or a dynamic group of those assets based on the value of a given tag, I can actually do that. Okay. And we're providing the operations to easily query the FIMS objects based on the value of the tag. So you can now create, you can easily create collections of objects simply by leveraging that single property here. If you had to do something like that before the construct of tags that we have created and we're exposing, you had to create custom extensions. It was possible, but it was a much larger effort to put in place. And there was no specific operation to query the custom extensions. Now we're jumping into external essence management. So what you see on the screen right here is, once again, the typical FIMS object. That's got 1 BM content, in this scenario, 1 BM content format type, and 1 essence there. Well, what about if that essence now is somewhere else, meaning that the repository doesn't control it. It knows about the essence, it knows it's located somewhere, but it cannot act on it. It cannot move it, it cannot retrieve it, it cannot delete it. You just need to be aware that it exists somewhere else. That's exactly the capabilities that we've added to the FIMS repository interface. From there, you keep track of the metadata of the object, you keep track of its locations into that whatever remote system it may be. And you could also leverage that same principle that we put in place to manage objects that are stored in the cloud. And that's actually one of the requests that we had coming from the FIMS community is, how do we actually create a repository, a representative repository where we actually take content and maybe that same content exists in multiple places, but there are places that we have no control whatsoever. And if there's something that we have no control over is, well, the cloud themselves. Those files that are stored in the cloud. There's interfaces that exist in order to store that content, to manage that content, but it's not directly controlled by the repository itself. Okay. So as an example, if you want to delete that file from the cloud, what you have to do is you have to go to the cloud, you have to use the interface that cloud service repository exposes, you have to delete the file, and then you have to update the object here. If you have an integrated platforms and now your repository has the capabilities of interacting with cloud services and to do exactly that, well, that external essence now becomes really a regular essence. Okay. So that's for the scenario. For the scenario of now, I have another slide on this one. I'm sorry, let me go back to here. For the scenario where you have a logical repository interface, where now you don't keep track of essences, but you keep track of location of essences as an example of a yellow page document where the phone, you basically browse to those yellow pages to find the number of the plumber, but you don't control the plumber from there. Well, that's the same concept here. You could actually create a FIMS logical repository that has links to many different essences that exist in other systems. It can be a MEM system, post-production, or regular file storage, and keep track of those things. Well, with the capabilities that we're adding, you will be able to do exactly that. The virtual asset. So this one is something that is totally new within FIMS, even if we are reusing a lot of the work that was done as part of the FIMS 1.2 project. And that's, in 1.2, we introduced the concept of partial content. And we're using that in this. So let me take you to this example. In this scenario, you have a repository system. That repository system has two assets. Okay? And I want to create an asset that is composed of those two other assets here. I actually want to use portions of those assets, like what you see really in red there. So my repository system may have the capabilities of really creating that asset by itself because it's got all the feature set that it needs to create the representations. So what we want to be able to do is to create a representation that is a combination of those two assets and create a brand new asset for that. Well, if that repository system can handle internally that virtual representations, well, there was nothing in FIMS that we could use to create that logic in terms of how those assets were related to each other as well. We've added that. So from here, there's a virtual representation similar to an EDL set of pointers back to the asset that exists to that repository that now can actually exist. From there, you still have a BM content format type and a virtual BM essence locator type that you don't manage. They are created automatically or derived by the repository itself. So as a consumer of the repository, what you end up doing, you end up using a FIMS asset that looks exactly like another FIMS asset, but it does that asset does not have a physical representations. So there may be, that repository will have the capabilities of rendering that asset and extracting it as a physical asset only when it's needed. Okay, if not, that asset can live as a virtual asset that is just composed of pointers to other assets. in terms of that was the technical side of what the FIMS repository 2.0 really contains. In terms of update on the project, well, the model has been updated and is made available on the FIMS GitHub. You can actually go there and see a lot of the schema and information that I just described here. The design for external essences and virtual asset is being finalized. We're still iterating in updating the schemas and the operations, and will soon be fully available on GitHub. The work in progress is currently available on the FIMS GitHub. In terms of the timeline, we're planning to release this version of the repository interface version 2.0 as part of the FIMS version 1.3. But you don't have to wait for the release to go get it. The FIMS GitHub is there. Please connect to it, and you can grab the latest version of the code. Thank you.